In 1924, we realized the universe was filled with galaxies, and in 1960, we saw point-like objects behind the galaxies called quasars. Today, we see galaxies at the distances of quasars and beyond. Quasars are a special type of galaxy, or really just the central region of extra bright ones. Here is the 2010 study that shows quasars and AGN in each redshift range. So between 0 and 0.1, there's about 6,500 AGN and quasars. Quasars are in blue, and they're brighter than this magnitude, and AGN are fainter. Z equals 0 is the present, and Z equals 2 is about 10 billion years ago. So nearby, and thus today, we don't see very many quasars, but in the early universe, they were plentiful. Extrapolating into the future, that means there will be no more quasars to study, so maybe we're just lucky. But you wouldn't expect to see this in a non-expanding universe. What you would expect to see is all equal volumes to contain the same amount of stuff. But you'd also expect to see the near objects better and less of the farther objects, so it would kind of slant off like this. This is assuming each redshift range, or bin, represents an equal volume. The standard bins we've been using are linear over Z and just go up by 0.1. In a non-expanding model, volume is not linear over Z. The observable region is a sphere with a radius of Hubble's length, so we can divide that by 10, find the radius, and calculate the Z. When we divide by 100, we get these as the first 10 or 11 bins. When we look at the data with these bins, we can see that the standard bins start near 0 and kind of bell up and over. But the non-expanding bins start at higher than that and just grow linearly. Let's look at a newer quasar catalog, the Sloan Digital Sky Survey. This is DR16, data release 16, and it has two main missions, one from 0.8 to 2.2, and the other anything greater than 2.1. You'll notice that there's an overlap and not really paying attention to the very low redshifts. So let's look at this data. We can go select DR16Q, and we'll see that we have very little to begin with at Z equals 0, and it comes up and over, and here's this overlap from the two surveys. So this is standard bins. We'll put it in non-expanding bins, and then we get more of a linear shape than we had before. And this is showing everything brighter than a -20. So we'll go to 21, and magnitude goes down in number as it actually gets brighter. It's one of those inverse quantities. So this is getting brighter up by 25, 26. You see that there's almost nothing here, and there's that bump where it overlaps. And these are the brightest quasars, 560 out of about 750,000. So we can also hit this plus or minus 0.5. So this is going to show us anything 21 plus or minus 5. And we see that they're all stacked up near us. And as I increase the magnitude, or as we get brighter anyways, then that peak is going to move away from us. So this distribution of quasars disagrees with the non-expanding universe. It's not what we'd expect. The universe could only be non-expanding if something was wrong with these measurements or interpretation. Is that even possible? Well, let's look at the cosmological parameters used by the study. This is Hubble's constant and the dark energy and matter densities. We see that it uses the 67.6 value for Hubble's constant, which disagrees with the data from the 0 to 2 redshift, which is what we were just looking at. And these are the supernova measurements. So this is the Hubble tension you're looking at, and it's over-predicting the distances. This choice of parameters places the objects farther away in theory, thus brighter in theory, but really not by a significant amount. What are some other factors? Well, here's a quasar found at z equals 6. This is a video by Pad Astronomy. There's a link in the description, and it is so much brighter than the other quasars at that range. Well, it was found to be increased by lensing, gravitational lensing. Here are 4 objects selected to search for double quasars. This is another video by Pad Astronomy, and in 2 of them, they are actually double quasars. There's 2 objects, and in a third, there's a star from the Milky Way real close by. So these objects were detected as one bright object rather than 2 in those cases. There are hundreds of billions of stars in our galaxy and hundreds of billions of other galaxies, but there are only about 1 million known quasars. The odds aren't actually that low that a star galaxy wouldn't fall near many of them. How about gravitational redshift? It is often brought up that the quasars could be gravitationally redshift. They come from supermassive black holes after all, meaning they're not as distant and bright as measured. All of these factors combined could skew the data. The SDSS quasar catalog visually inspected most of them in the lower redshift range, and has led a lot more of the higher redshift range through, and is also again very sparse at the lowest ranges. This is one of the first quasars ever measured. It's at z equals 1.58 with an absolute magnitude of negative 26.7. But in the SDSS data, there is nothing around that magnitude lower than a redshift of 0.2. So the SDSS data only tells part of the story. Future studies like DESI will be able to tell us more. This is from the early release data, and we see that the low redshift bin is already higher than it was in the previous data set. Looking at it with the non-expanding bins, it tells a pretty different story. So this is only 1 to 2% of the data DESI will produce, and it doesn't have the magnitudes yet, so we can't slice it up the way we did with the previous data set. When more data is released, I'll tell you all about it. Here's a couple more things to think about. In the Pad Astronomy double quasar video, he noted that the Milky Way and Andromeda collision in the future possibly will create double quasars. Our own galaxy becoming a quasar when they're supposedly going extinct. And we recently observed a galaxy become active. This was at 0.024 was a redshift. So maybe the quasar's place in the evolution of galaxies is misunderstood. What do you think? Are quasars the dinosaurs of the cosmos, ruling the early universe but then going extinct? Or have we been misunderstanding them and their properties? Let me know in the comment. Thanks for watching. Have a great day.